students, shall we start the example? Okay, once again, good morning students. You can see we are going to solve the next very important example in Fourier series. We already solved the example taking the interval 0 to 2 pi, minus pi to pi, and now we are going to take from 0 to 2. So this is also very simple example students. First you have to remember this formulas, that is f of x is equal to a naught upon 2 plus summation n1 to infinity an cos n pi x upon l plus summation n1 to infinity sin n pi x upon l. A naught is equal to 1 upon l integration c to c plus 2l f of x dx. An is equal to 1 upon l integration c to c plus 2l f of x cos n pi x upon l dx. Bn is equal to 1 upon l integration c to c plus 2l f of x sin n pi x upon l dx. So this formula you have to practice throughout this unit. Yes, that is Fourier series, which is very very important. We have seen the applications, we have seen how the examples are there. Yes, you have already have told you about the very important concept that if you know the formula, that is if you know this formula, in this formula you have to substitute only a naught, an and bn. So that's finished. After solving these three values in this formula, you will get the Fourier series. Is it clear? Okay, so we'll start one by one. So you can see first what are the things given here. So I'll write here given. What is given here student? Yes, the function they have given f of x is equal to e raised to minus x is given. Okay, and they have given the interval, that is c to c plus 2l. This is our interval. They have given already, it is 0 and 2. Means you can see here that implies c is 0. Okay, so this is one of the way you can identify. So when c is 0, you can see, compare this equation and this equation, this c is 0. Okay, so when c is 0, then c plus 2l is equal to 2. So you can see c is 0, so 2l is equal to 2, and then you can identify student very easily that l is equal to 1. So this is our length. Please remember this. Like this also we can also solve this length. Now what is required here students? So first I will try to solve the a naught. So please remember the formula. A naught is equal to, you can see here, it is 1 upon l integration c to c plus 2l f of x dx. So substitute one by one. So first I will substitute L is equal to 1. Okay, here you can see why L is equal to 1. I already told you students. So please go through that once again. Then we have the integration. You can see the interval. This is our interval. Please go through this interval once again. So you can see it is 0 to 2. So this is, our length is 1. So I have taken here 1. Integration is from 0 to 2. Then f of x. What is f of x students? Yes, it is e raised to minus x student. So this is, I will substitute e raised to minus x, and d of x remains as it is. So once again I'll repeat this. See, yes, those who are late, just please go through this once again. See, obtain the Fourier series for f of x is equal to e raised to minus x in the interval 0 to 2. First you have to write this formula, very very important. See, I will tell you one secret that if you know, if you don't know, just by heart this formula and rewrite in the exam. That's it. You will at least get 1 or 2 marks. Okay, then substitute the values. F of x is equal to e raised to minus x. Okay, then you have the interval c to c plus 2l, that is 0 to 2, where you can compare this both. You can identify c is equal to 0 and l is equal to 1. So this values I have substituted in a naught. What is a naught students? Yes, one question, 1 marks question they may ask. A naught, an and bn are nothing but Euler's. By Euler's formula we have a naught, an and bn coefficients. So please remember this. So just simple integration student, this is equal to, you can see now, integration of e raised to minus x. So what is e raised to minus x students? Already you know. I'll just show you the integration. E raised to ax. So what is integration of e raised to ax dx? It is nothing but e raised to ax upon a. So you can see a is here minus 1. Okay, substitute e raised to minus x upon minus 1. So you can see here we have minus 1. Okay. Yes, then this integration is from 0 to 2. Okay, now substitute wherever x is there. First we will substitute x is equal to 2, and then we will substitute x is equal to 0. Yes, students, you can try yourself. See, a naught is equal to, you will get it like this, that is e raised to, first I will remove minus outside. Please remember, minus 1 I have removed outside. E raised to minus 2, then e raised to, it is minus 0. So now if you simplify, you will see that, students, I don't know why this is writing anywhere. Okay, so this is equal to, minus is outside, I'll write minus as it is. You can simplify this, students. E raised to minus 2 can be written as 1 divided by e raised to 2. This is minus e raised to 0 is nothing but 1. Okay, now please simplify like this. I can see here minus, I will keep it as it is. I will take the LCM. Okay, this is divided by e raised to 2. This is 1 minus e raised to 2. So this is what I will get. If I bring this minus inside this bracket, so you can see this will become e raised to 2 minus 1 divided by e raised to 2. So this is what we get, a naught. So very simple it is, students. You have to calculate a naught, an and bn, and substitute in the Fourier series formula. You will get the answer, you will get the result. Okay, now please try, students, you also try with me. An formula is there, values I have given. You also sit and try to solve this example, so that you can see, you can compare my answers and your answers, so that you can see where mistakes, you can rectify your mistakes. So after a naught, I will go to solve an. So already you know the formula, that is an is equal to 1 upon L integration c to c plus 2L f of x cos n pi x upon L dx. So I will substitute one by one. That is L, I will substitute, this is 1, students, and the interval they have given integration 0 to 2. Then this will remain as it is, f of x. Then you can see here cos n pi x, L is 1, so I have taken it as 1 only. Okay, now you have to simplify this integration. So very important, students, you must be perfect in the integration and differentiation. That will be very easy. So this is equal to, now you can see I will substitute f of x. What is f of x, students? Please remember it is e raised to minus x. So I will substitute here e raised to minus x. Remaining terms, please keep it as it is. So this is equal to, now you can see here, students, I have already given the formula, as you remember. So once again, I will rewrite that formula here. Just I will move the cursor this side. Okay, so I will write the formula, that is, please remember this formula and practice, student, that is integration e raised to ax cos bx is equal to, yes, it is e raised to ax upon a square plus b square. Okay, so here you can see it is a cos bx plus b sin bx. This formula directly you have to remember and substitute it in this value. So now you can identify very easily. Here we can see, from this you can identify what is a value, students. Yes, it is minus 1. So minus 1 a is there. And what is b value, students? Yes, you can identify here b. Where is b? Here is b, means b is this. This is our b. So therefore b, I am going to take this as n pi. Okay, so now this will be, this will go, and you can see I'm going to write the same integration in this form. Okay, so now substitute the values one by one. So this is equal to, you can see it is e raised to minus x divided by a is minus 1. Please remember minus 1 square plus b is nothing but n pi the whole square. Is it clear? Okay. Now you can see again a is minus 1, so I have taken minus here. This is cos, yes, b is again n pi, so I will substitute n pi x as it is, plus b is n pi, yes, then sine n pi x. So now you can see wherever a is there, yes, in this you can see wherever a is there, I have substituted minus 1, this is also minus 1, and wherever b is there I have substituted n pi, this is n pi, and this is n pi. So everything I have substituted here, and please remember the interval from 0 to 2. So first I will substitute the value for 2, and then I will substitute the value for 0. So wherever x is there, before that you can see here some constant terms I will remove outside. Okay, and also please remember this one very important formula, that is again sine n by x, yes, n by x or n pi, yes, sine n pi is always equal to 0, and this is equal to sine 0. Sine 0 is also 0, sine n pi is also 0, or we take this as n is nothing but 2. So you can put it in the radian, and you can check in the calculator that sine 2 pi is 0. Means this term, when I substitute x is equal to 0, you can see sine 2n pi will be 0, and which is nothing but again sine 0. Means if I substitute 2 in this term will be 0. If I substitute 0 also, sine will become 0. So means only this part is remaining. So you can see I will take minus outside. Okay, I will keep this minus outside. Whatever constant terms are there, I will remove it outside. Minus 1 I will take, divided by, I can see this is also constant, students, so I will remove it outside. So 1 square will become 1 plus n square pi square. So what is remaining, that is x terms, it is e raised to minus x cos n pi x is remaining. This is 0 to 2. So this is how you have to identify the terms and simplify very easily. Now substitute the value of 2 and then 0. So okay, no problem. So we'll simplify this, students. So this is equal to minus 1 upon 1 plus n square pi square. Now first I will substitute 2. This is e raised to 2 cos n pi 2 minus, now you can see this is e raised to minus 0, and then this is e raised to n pi 0, students. So I have substituted 2 and 0. Again you can just see, identify which formula you can substitute. Yes, that is cos 2n pi is always equal to 1, which is again cos 0. So cos 0 is 1, cos 2n pi is also 1, students. Now substitute and simplify. So this is equal to minus 1 upon 1 plus n square pi square. Okay, so this is e raised to minus 2 you will get. I can see this is 1. Okay, this value is 1. Okay, so I'll substitute here 1 minus, see you can see e raised to 0 is also 1, as well as cos 0, because cos n pi 0 means cos 0, it is also 1. So I have substituted, this is equal to 1, students. Okay, now simplify, just simplification is there, so I will just go for simplification, which is equal to minus, I will take it inside this bracket, otherwise you can keep it outside. For simplification I will take this minus inside this bracket, students. Okay, so this will be like this. So 1 minus e raised to minus 2 divided by 1 plus n square pi square. Further, you can also simplify like this, 1 minus. So e raised to minus 2, I can write it e raised to 2. 1 divided by e raised to 2. So 1 plus n square pi square. Further, if you simplify, you can take LCM, multiply here e raised to 2, multiply here 1. So you will get it like this, e raised to 2 minus 1 divided by e raised to 2 divided by 1 plus n square pi square. Further, you can simplify if it is necessary, e raised to 2 minus 1 divided by e raised to 2 1 plus n square pi square. So this is what we have calculated for an students. So what is remaining now? Yes, we are remaining with bn. Okay, no problem. So use this formula, bn formula I have already given. Bn is equal to 1 upon L integration c to c plus 2L f of x sine n pi x upon L dx. So take this formula, substitute the value, L is equal to 1, f of x is equal to e raised to minus x. Okay, so then after simplifying, what I will get here, students? Yes, I will get here, sorry. Yes. So what I will get here, students? Okay, so I will get here bn is equal to, L is 1, so I have taken this as 1 only. Then integration from our interval is 0 to 2, so substitute here 0 to 2. F of x is minus x. Okay, then next we have again sine n, sine n pi x upon L. L is 1, so no need of writing again. This is dx. Again, you can see this, students, whenever there is e and cos or e or sine, please use the simple formula, that will be helpful. Okay, so I will use this formula, that is e raised to, again I am going to take this as ax sine, I think I have told you to remember, please remember this very important formula, which is equal to e raised to ax upon a square plus b square. You can see this is a sine bx minus b cos bx. So please identify what is a b. Yes, you can easily identify, students. You can see a, I have to take here minus 1 and b will become n pi. So you can see this is our b and this is our a. So you can see this is a and b. This two, if you identify, then you can substitute the values. This is equal to, directly I will substitute in this formula, students. So I will get this as e raised to, again this is minus x upon minus 1 square plus n pi square, because b is n pi and a is minus 1. So this is again minus sine n pi x minus n pi cos n pi x. Is it clear, students? So again, please remember the integration, that is 0 to 2. So the interval will be from 0 to 2. So this formula you have to please remember this and practice this formula, students. That will be helpful. Okay. Now further, if you simplify this, yes, just substitute the values. X is equal to 2 and x is equal to 0. First, I will use the formula, that is, you can see, please remember the formula now, friends. It is very helpful and important now. Okay, so now you can see, that is sine 2n pi. Yes, sine 2n pi is 0 and sine 0 is also 0. Please remember this, friends. So now you can see in this term will become 0, because if I take 2, it will become sine 2n pi, which is again 0. If I substitute x is equal to 0, it will become sine 0. It is also 0. So what is remaining here, students? So you can see there is a constant terms I am going to take outside. So this is constant. minus n pi is constant and this term is constant. So I will remove it outside. So I will get this bn is equal to minus n pi upon 1 square. I will take it as 1 plus n square pi square. So what are x terms here is remaining with e raised to minus x is remaining and cos. Yes, you can see cos n pi x is remaining because I have to substitute x is equal to 2 and x is equal to 0 students. Okay, now you please substitute the values. You can see bn is equal to okay. So this will be now minus n pi upon 1 plus n square. Pi square remains as it is. Substitute first x is equal to 2. Okay, so I will substitute x is equal to 2. So this is e raised to minus 2. This is, and this is again cos n pi 2, and this will become again minus. Now substitute x is equal to 0. So this is e raised to minus 0 and this is cos n pi 0. Again please same formulas again and again we are using students. Now it should be perfect. Yes, which formula is useful now? Yes, I am going to use cos 2n pi is equal to 1, or you can see it is also cos 0 is also 1. So now you can see this is equal to, it is minus n pi divided by 1 plus n square pi square. Okay, so you can see this will become 1, this value will become 1, and this value will become 1, and this value will also become 1. So e raised to minus 2 minus 1. This is what we get the value. Next, further if you simplify students, this is equal to, I will take this minus inside this bracket, okay, to make this value positive. Therefore n pi upon 1 plus n square pi square. This bracket, in if I take minus inside this bracket, this will be 1 minus e raised to minus 2. Further if you want, you can simplify this as n pi upon 1 plus n square pi square. Then you can simplify this ones, 1 minus 1 upon e raised to 2. Yes, e raised to minus 2 I can write 1 upon e raised to 2. Okay, now take LCM, multiply here e raised to 2 and I will multiply here 1. So this is equal to n pi upon 1 plus n square pi square. This value you can get like this, that is e raised to 2 minus 1 upon e raised to 2. So this is what we have calculated bn. So now you can see you have calculated an value, you have calculated a naught, and you have calculated bn, and all these values you just simplify in this Fourier series formula one by one. So now what will be the answer, friends? Therefore you can see f of x is equal to, first I will take a naught. A naught you know already, a naught upon 2 this is. So we can see e raised to 2 minus 1 upon 2e plus, yes, next substitute an. So summation n 1 to infinity an, what we have students, it is e raised to 2 minus 1 divided by e raised to 2 1 plus n square pi square, and this value is cos n pi x plus, I can see again bn. So now I'm going to substitute it here bn. So what is bn here students? It is n pi. Yes, you can see e raised to 2 minus 1 upon, this will become e raised to 2 1 plus n square pi square. Okay, then it will be into sin n pi x. This is our Fourier series. Is it clear students? Yes, if you have any doubt please ask me.